Good morning, children. How are you? Today we will be doing, hope you are started writing your journals. I have given you the cation analysis document, as well as I have given you the instructions also as how to write down your journal. So please do the nice work. And now we will see some other work also over here. Just watch this. Some videos are there. They're very important because you should know what type of a reaction. Last time we did that is for 30th of March. I had given you catalytic oxidation of ammonia and Oswald's oxidation. You can watch this. Ammonia is mixed with air. 1:10 passed over several layers of hot platinum. Reaction can be demonstrated using concentrated ammonia solution. So they have taken concentrated ammonia solution, that is liquor ammonia only, saturated solution of ammonia. They are just swirling it to keep the vapor. This is a saturated solution. Platinum ion is heated on a burner and suspended. Now check what happens with platinum wire. See, platinum wire started glowing. It becomes red hot. And because of this platinum wire, then further heating is not required. It catalyzes the oxidation of ammonia. So it gives you nitrous oxide, that is NO. And NO converts to nitrogen dioxide. 45-46, that is known as catalytic oxidation of ammonia. Till 45-46. Keeps going brightly until either the ammonia is poured. Now this is also further used in the preparation of nitric acid. That is the Oswald's process. You can even use the chromium oxide, that is Cr2O3, instead of platinum. But I think platinum is in our syllabus. This is also very nice effect. This chromium oxide can be obtained how? By decomposition of dry heating of ammonium dichromate. That is a voluminous precipitate, voluminous residue, not precipitate, residue, which forms a very high exothermic reaction. And with the light, see, these are the kind of fireflies. Water vapor condenses on the sides. Bright sparks. Looks like fireflies, isn't it? Okay, now you can also see some other things like you have here. This is also there.
Nitric acid. After ammonia became available on reducing a portion of it back to nitrogen in the water decreases. Thus, the gas is liberated. We might show the setup of a gas generator in an upcoming video. For the oxygen, we use plain air, which, as we know, contains about 21% of oxygen. Do not use pure oxygen if you don't want to blow yourself up. As we mentioned
So
earlier,
platinum.
you'll need the platinum catalyst. This can be a solid piece of platinum, for example, a wire, sheet, foil, etc. However, we'll use the slightly specialized catalyst. This is fused silica wool with a thin deposit of platinum on it. The whole catalyst you see here contains less than 10 milligrams of platinum. However, its surface area is comparable to that of a soccer field. If there is interest, we might show you how to prepare the catalyst in a later video. Basically, all you do is to first dissolve the tiny piece of platinum in aqua regia. Then, you'll add sodium chloride and precipitate out sodium hexachloride.
Not in our syllabus, we just have to see that the platinum. Yes, you can see this.
On the left, you see the source of ammonia. This is a small Erlenmeyer flask with some 30% ammonia solution. It is stoppered with a 2-hole rubber stopper. The tube on the left leads to a small air pump. The air is then bubbled through the ammonia solution. This results in the mixture of air and ammonia. This mixture is laid out through a drying tube filled with calcium oxide on the right. This removes any residues of water as those would cool down the catalyst later on. Now, the mixture is introduced into the combustion chamber. This consists of a fused silica tube with stoppers and the catalyst in the middle. It is important to use a tube made of fused silica, as a regular glass would first bend and then melt. The air-ammonia mixture is entering the tube on the left. Thereafter, the products are let into a large gas washing bottle. This absorbs the nitrogen oxides and produces the nitric acid. We start the airflow and bubble the air through the ammonia solution. Next, we heat the combustion chamber with a gas burner until the catalyst glows bright orange.
Catalyst has been heated, initial heating has been done. Then catalyst starts glowing, that is platinum. This is actually, it is done in a more scale. You will be able to see this platinum started glowing now. Brightly it glows.
Let's remove the heat source and see what happens. The catalyst continues to glow as the reaction takes place.
One of the observation, catalyst continues to glow.
It's actually quite a nice color. Let's switch up the lights and enjoy the show. Closely now, you'll see brown clouds of nitrogen dioxide appearing in the subbat prevention flask. We let the apparatus run for a while in order to generate the nitric acid in the gas washing bottle. Here we are a few minutes into the reaction. We switch off the airflow now. Each of the solution in the gas washing bottle. It is strongly acid, indicating the presence of a strong acid like nitric acid. To prove that we have prepared nitric acid.
Okay. You can also see some other things like ammonia. Yeah, this is also very good.
Ammonia is a very important industrial compound. It is used in the manufacture of washing soda, in a number of fertilizers. It's also used as a refrigerant. One should know how ammonia can be prepared in the laboratory. And for this, we have a setup which comprises of a hard glass test tube. Its mouth is closed with a 1-hole rubber cock. You can find the delivery tube passing through it, the other end of which leads into a lime tar. And over the lime tar, we have an inverted gas jar which is clamped to a stand, which means we have 2 stands in this experiment. Can you think why the gas jar has been inverted? Ammonia is lighter than air. It is collected by the downward displacement of air. What are the chemicals that are involved in the preparation of this gas? You can find in the test tube, we have taken ammonium chloride and calcium hydroxide in the ratio of 3:2. In the lime tar, as the name suggests, some lime has been put which will absorb the water, and dry ammonia will collect in this gas jar. One needs to heat the mixture of ammonium chloride and calcium hydroxide. You can find water droplets have already collected on the cooler sides of the test tube. For a quick preparation of ammonia, we can carry out the same experiment in a hard glass test tube.
Let
us
me
do
show
that.
you in the.
I have taken the reactant mixture
Yeah.
in a hard glass test tube. I can smell strong ammonia dipped in concentrated hydrochloric acid. Test the evolution of ammonia. I can take a glass rod dipped in concentrated hydrochloric acid
That is test for ammonia.
and let me hold it near the mouth of the test tube.
Dense white.
You can observe dense white fumes. Ammonia has combined with hydrochloric acid to form ammonium chloride. As I am heating the mixture, I can get a strong smell, a strong pungent smell of ammonia. How do I test the evolving gas? It is colorless. I dip a glass rod in concentrated hydrochloric acid, take it near the mouth of the test tube, paper. This is a red litmus paper. I make it moist by dipping it in water.
You don't have to write this test.
Let me hold it near the mouth of the test tube. I find that the litmus paper has turned blue.
Blue. So it is basic in nature. Red, moist red.
A red litmus paper turning blue tells us ammonia is basic in nature. Paper. I'll dip it in. Let me now take out this gas jar.
Just collected the gas, ammonia gas. Ammonia gas is lighter.
And cover it with the gas jar lid.
That is a downward displacement. They are not.
A glass rod dipped in concentrated hydrochloric acid.
With the dense white.
You can find dense white fumes.
So 3
and when I dipped a glass rod, which
now this is a fountain experiment, as you can see.
You can find the litmus solution, red litmus is rising up the glass tube.
It will emerge as a blue color fountain, right? This is a basic. Slowly it will.
And you can find that as ammonia is coming down, it's dissolving in the litmus solution. Ammonia is highly miscible in water and the red litmus is turning blue.
The high solubility of ammonia gas has been shown by this experiment.
You can find the blue litmus solution has risen up the glass tube and ammonia, as it is coming down, ammonia is highly miscible in water. It has turned